Algebra 2, Section 1.3, Solving Equations, we're dealing with properties of equality. So basically, we're going to be dealing with how to keep equations balanced and equal. So for example, the reflexive property says that basically a number equals itself. Pretty common sense. Negative 7 plus n equals negative 7 plus n, 3 equals 3, 4 equals 4. Now this might not make any sense in the problems we're doing now on why we need to state that, but when we go into more geometric proofs, you'll see more why. Symmetric is basically the equal signs you can flip. So if I have 3 equals 5x minus 6, if I switched it and put 3 on the other side, it still equals 5x minus 6. I haven't changed anything in the equation. I just took the whole equation on one, the whole on the other, and I switched them on both sides. Okay? So basically if I have x equals 7, it's the same thing as saying 7 equals x. They mean the exact same thing. Next is transitive. And what that means is that if I have 2x plus 1 equals 7 and 7 equals 5x minus 8, then, because they both equal what number? This one equals 7, this one equals 7. So I can make them equal to each other. So the transitive is a very important one. So let's say that Pastor Paris and Dean Greg are both the same height, then that means that they are interchangeable. Okay? So if I say that Dean Greg is maybe 6 feet, then you also can assume that Dean Sheldon is 6 feet as well. That's a transitive property. Because they equal the same thing, then you can make them equal to each other. Okay? The substitution property is basically you can substitute. If I have 4 plus 5 means the same thing as saying 9. So therefore they become interchangeable. 4 plus 5, m, is the same thing as saying 9m, and they both equal 18. So those are basic properties of equality. The next one is a very important one. It's one that they try to show you in your book with addition and subtraction, but a lot of it is basically this. What you do on one side of the equal sign, you absolutely have to do on the other side of the equal sign. It's in order to keep it balanced. So if I added 3 on one side, I can't just leave it like that because then I've changed the whole equation. I have to also add 3 on the other side. It's like keeping the scales balanced. If you're going to put, let's say, 10 pounds on one scale and then 10 pounds on another, and then you add 3 pounds to one and not the other, then they're no longer equal. So in order to keep the equality, make sure that you do the same thing on both sides. For example, if I want to solve these equations, I need to isolate the variable. Isolate means that we want to get rid of all its friends. We want to make sure that the variable is by itself. So n plus 3, well, what's connected to n? Plus 3. In order for me to get rid of positive 3 so that n is by itself, I have to subtract 3. Positive 3 minus 3 automatically eliminates and I have n. But the thing is, because I did it to one side, I have to keep it balanced or I no longer have the same equation. So since I minus 3 here, I also have to minus 3 here, making negative 11 minus 3, which would give me negative 14. That makes sense? Same thing here. What's attached to the y is my negative 3. And I have to get rid of it by doing opposite. Because it's being times by negative 3, I have to divide it by negative 3. So here I'm dividing, but again, because I do it to one side, I have to do it to the other, so y equals negative 2. So one more time, the main point of the properties of equality is what you do on one side, you have to do on the other. So here we have our first example. It wants us to solve. So it says to solve each one, and when we solve, that basically means that you isolate for a variable. You get the variable completely by itself on one side of the equation. Well, in this case, what's attached? S minus 5.48. So we need to somehow get rid of that minus 5.48 by doing the opposite, which is to add 5.48. So I'm going to add 5.48 on this side. So that means I have to do it on the other side. Add 5.48. So this gets me what I want, which is, this means it's canceled out, so this gets me s by itself. And now 0.02 plus 5.48 gives me 5.5. Next is similar. We have to isolate, but this time it's being attached to 1/2. Okay? And what I need to do is I need to get rid of 1/2. So the only thing, the best way to get rid of any fraction is just to multiply it by its reciprocal. And reciprocal is basically the opposite. So you just flip it. You flip it and multiply. So instead of 1 over 2, I'm going to do 2 over 1. This is being multiplied by its reciprocal, so it automatically cancels out. Okay? But because I multiplied it by here, I have to multiply it by here. And since 2 over 1 is the same thing as saying 2, okay, then I would multiply them together, which is 36 equals t. Alright, if that makes sense, go ahead and try page 23, number 8. That's going to be part of the problem that you're going to need to have answered when you come to class. So page 23, number 8. And please remember to do your vocabulary. Please remember to write these down after or before I start talking. Our next problem is asking us to solve. This problem is going to have some distributive properties in it. And remember from the last section where we need to distribute. So according to the order of operations, those go first. So I'm going to go ahead and bring down 53 over here because I can't do anything on that side. So we're going to take 3 and we're going to share it with y, which gives me 3y. We're going to also share it again with the whole thing. So not just 2, but -2, giving me a -6. Okay? Just like the other section, I'm going to take all of this, which is -2, and share it with a 3y, which gives me a -6y. If it gives me a positive, this would be a plus, but it's a negative, so -6y. And I'm also going to share -2 with all of this. Remember, don't forget the sign. It's very essential, or else your whole equation will be off balance. So negative and a negative give me a positive. So -2 times -1 is a positive 2. Alright? So we have 53 equals, and now we're going to combine like terms. 3y and -6y, and I underline it so I show that I've done it. So if anything is not underlined, that means I haven't used it yet. So 3y minus 6y gives me -3y. Okay? And then -6 plus 2 gives me -4. My next step is, again, because I want to isolate -3y, I need to get rid of this -4. So I'm going to add 4 to both sides. This gives me 57 equals -3y. We divide both sides by 3, and we should, this cancels out, and we end up with, because this is a negative, this becomes a -19 equals y. That's my answer. That one was a bit longer than the first one. Go ahead and try page 23, number 10. Page 23, number 10. Our last problem is kind of like a test, a question that they might give you in the SATs. So basically, it's asking, if 4g plus 5 equals 4 over 9, what is the value of 4g minus 2? So here's the difference. 4g minus 2. We wanted to make it look like 4g minus 2. What we have is 4g plus 5 equals 4/9. So look at this. Ignore this real quick and look at the difference. What is the difference between the top and the bottom? 4g is the same, yes? So what's next is this. This is -2 and plus 5. So how do I get from -2 to positive 5? What's the difference between this? That means if I subtract 7 from this, 5 minus 7 gives me a negative 2. So I'm going to subtract 7. Okay, 4g then equals, 4g, this becomes negative 2. Does that make sense? I subtracted negative 7 from there, negative 2. That's exactly what it looks like. But the problem is, like the property of equality, whatever I do to one side, I have to do the other. So since I've subtracted negative 7 here, I have to subtract negative 7 here. Okay? When I'm doing that, I have to make this into a fraction because this is 4 over 9. This is 7 over 1. So now I have to multiply the bottom, which is, I have to multiply both sides by the same number. If I want the denominator by 9, okay, that means I multiplied this by 9. And just like the equal sign, the fractions work the same thing. Whatever I do to one, like the bottom, I have to do the top and vice versa. So if I multiply this by 9, I also have to multiply what? The top by 9. Whatever I multiply the top by 9, bottom by 9, I also have to multiply the top by 9. So 7 times 9 gives us 63. 4 minus 63, okay, because when I'm subtracting fractions, the denominator stays the same. As long as it's the same denominator, it stays the same. And I subtract the top. So 4 minus 63 equals negative 59. So the whole point of that is to try to make this look like this by just manipulating it the way you want. You can manipulate the equation any way you want. You can add, multiply, whatever it is, but the one rule that you have to stick to is whatever you do on one side, you have to do on the other. So, for the last problem, you're going to do page 23, number 15. So go ahead and try that, and then bring those 3 problems to class.